Hi guys, so I'm going to show you how to build something like ChatGPT. Now, of course, this won't be nearly as sophisticated as something like ChatGPT 4 because that requires compute really beyond the reach of anything you can get as a consumer. You need an entire data center just to run the model, but you can get fairly decent results from running a large language model that is the thing that drives ChatGPT on your local box. Now, you can run this on a fairly decent laptop or desktop. It really works better if you have an NVIDIA GPU, but you don't have to. You just need something with a decent CPU and probably around 8 to 16 gigs of RAM, and that would work for what you're doing here. And now it might take longer to run some of the queries, but it will work and you can get some fairly decent results just by running this on something like a CPU. Now, I'm going to be using a much more powerful box than most people typically have, but you don't need a box like mine to make this work. So with all that said, let's just dive right in. I'm going to show you how to use local GPT to do this, and then we're going to show you how this application actually works under the hood and look at its APIs and things like that. And then I'm going to show you how you can use something like Postman to run queries against it, so you can use this in your own applications if you wanted to install something like ChatGPT in an edge context that doesn't have an internet connection or something like that. So if you're not familiar with the idea of ChatGPT, the interface for it is pretty straightforward. It's like a chat application. Now, of course, behind the scenes, this thing is doing a lot of very sophisticated AI, but the interface is really pretty straightforward. You just use natural language to express some kind of curiosity or some kind of interaction. So you can say, write me a poem about flowers and phones. And it's going to attempt to write a poem about that. Now, I didn't program it to do this. It's just using the context of poem, flowers, and phone to give some kind of nonsensical poem about that, and it's able to rhyme and do all these other kinds of things. And this is really what generative AI is able to do. It's just being able to produce meaningful text based on the context of what you're putting into the particulars of your chat. So there's a lot of different things that you can do with. I have a video on a lot of the things that you can do with ChatGPT, but this is the essence of what you can do with it, and that is just basically work with text in all different kinds of settings. So with this in mind, we're going to attempt to build something like this using a project called LocalGPT. So this is the repository that we're going to be using. Now, this is LocalGPT, and this is a very popular open source project for doing the very thing that we're trying to do. And it's very easy to use. So I really liked this particular one over some of the other implementations just because it's pretty straightforward. There's not a lot of hassle with this one. So to use it, you're just going to clone the repository. So I would recommend using WSL on Windows if you're using Windows. Of course, you can use a Mac or a Linux box. On Windows native, it tends to be a little kludgy. So I wasn't impressed with that implementation. And that didn't have anything to do with this particular project as much as it had to do with the integrations with CUDA and some of the other things that this uses as part of the Python libraries that it includes. So with all that said, I just went over to WSL and I have CUDA enabled on WSL, and therefore I get the advantage of a GPU in WSL. If you have a laptop with Linux with a GPU, that's great too, and it will work fine for that. In any case, let's go ahead and clone this repository. So I just grabbed the URL right here to clone it, and I'm just going to put it in my source folder right here. The location doesn't really matter as much as just getting it to git clone, and just paste in the URL, and it's going to clone down the repository. And so let's get into that folder and let's install the dependencies. Now, I'm going to assume that you have Python and pip installed, and I'm using Ubuntu, so I just went through the motion of installing Python and pip using Ubuntu, and it worked. And after that, you can just do pip install, and you can do -r and then do requirements.txt, and it will download and install all of the packages. And so I've already done this for another folder that's using this project. I have all these, but once it's downloaded, everything's set and ready to go. So that can take a minute to do. But after that, you're ready to actually run the first instance of this. And this is where it's going to download a model, and it's going to enable you to interact with it on the CLI. So let's do that part next. So after you've installed the dependencies, you can get a list of the files in this particular folder. Now, the one that I'm going to be most interested in just right off the bat is this one right here, run local GPT-py. So I'm going to run this one. So to do that, just run Python 3 and put in the file name and run it. Now, if you've never run it, it's going to download a model. And part of that download is going to get the model from a repository. You can see it's downloading right now. And then after it downloads the model, you'll be able to use it. So depending on the speed of your internet connection, this could actually take a while. It might take only a few seconds if you have a fast internet connection. But in any case, once it's downloaded, it'll unpack it, it'll load it, and you'll get a prompt. And so we'll come back whenever I get the prompt ready. Okay, so now I've downloaded the model and it's up and running. I'm able to enter a query at this point, and this is what you expect to see once it's loaded. But this particular model is Llama V2, and it is a model with about 7 billion parameters. Now, parameters are basically a measure of the sophistication of a model. Now, 7 billion might seem like a lot, and certainly it is for a local context, but against GPT-v4, this is actually a fairly small model. GPT-4 has over 1 trillion parameters, so it's orders of magnitude more sophisticated than this one right here. But even with that said, this particular model is very capable, even in its smaller state. So if I wanted to put in that same prompt I did a minute ago against GPT-4, I'm going to say, write me a poem about flowers and phones. It is actually able to do that. So let's let this run. It's going to ramp up my GPU in the background, and you might hear it actually spin up, and you might hear fans getting louder, but that's because it's processing this particular request. Now, it takes a few seconds to process it, and once it's processed, you should see a poem in the output down below. Okay, so now there is the output. Here's the poem. It said, flowers bloom in spring's gentle kiss. Their petals are soft, their flowers colors so bright. But as many sway in the summer breeze, their beauty is threatened by the light. For into the world of technology where screens dominate our sight, the flower fades, their magic lost, as phones take over day and night. So it does have some rhyming scheme there, and it is a poem that actually makes sense. So something to think about there. It is able to write a poem. So this is one application for this, of course, and there's a lot of other applications that you can use this particular model for just as is. But one of the cool things about a model like this is its ability to use your own data. And most models will allow you to use your own data, even GPT-4 if you want to do that, which I'm going to do a whole different video on how you can do that with Microsoft's OpenAI. But for today, we're going to look at how to use local GPT to take your own data and put it into a folder. And it's basically going to take that data and put it into what's called a vector database. And the vector database then resembles something like a model that you would use. And then it's able to use that vector database in the same way it uses this kind of built-in database to basically get intelligent responses out of a set of documents. So let's go look at how you can do that. And it's actually pretty easy to do as well. So to make this work, you need some kind of source data. Now, it needs to be some kind of text data, generally speaking. So that would need to be like Word documents or text documents or Markdown files or PDF documents. All of these that have different kinds of text in them, you can use that as part of the source data. You can also use comma delimited files if you want to use that as well. So to make that work, you just paste the documents into this source documents right here. Now it comes with this PDF file right here. I'm going to remove that file. I'm going to paste in the manuscripts for my novels. Now I've written several novels and I got several in the works right now, but these are the 4 novels that I've published. So what I'm going to do is I'm going to ingest these 4 novels, and then I'm going to ask it questions about the novels so I can get information out of these hundreds of thousands of words that I've written in these novels and see if it's able to return intelligent responses. So with that, I've pasted them into this source documents folder, which is in the local GPT folder. Now I did this in Windows, and this is using WSL. I can get to this folder. You didn't have to figure out how to get those into whatever folder you're using on your particular platform, but in WSL, it's pretty straightforward. So coming back down here, I'm able then to use WSL to show you that I'm looking at source documents right here. It's in that same folder. And if I do ls dash source documents, you can see that I have these Word documents right here. Now to ingest these, it's pretty straightforward. Just run Python, a Python script called ingest.py. and it will read the documents out of this folder right here, and it's going to build a local database against the data in those. So let's go ahead and run that and let it run. It can sometimes take a few minutes to do that, so you'll have to let it calculate all of the different vectors that it's going to be using as part of this parsing process. And once it's done, you'll see an output hits finished, and then you'll be ready to go with all of your local data. Okay, now that that's done, we can restart the model again, and now it's going to be able to use that local database that it created from my source document. So coming right back up to this, let's go ahead and run local GPT again, and let it then load this new database. And of course, it's going to load the model as well. And as soon as it's done, we should be able to ask it questions about my novels. Okay, now that it's up and running, we can enter in a query about my novels. I'm going to ask it about one of my main characters. Can you tell me about Kamen? Kamen is the name of one of the main protagonists in the first 3 novels that I wrote, which would be 3 out of the 4 of this one. And this will then try to query those documents. Basically, it's going to use that database it built after it parsed the documents, and then it's going to use the model to produce hopefully an intelligent response about the content of my novels and give me something about the character by asking about it using this particular prompt right here. Okay, so this is the answer it gave. So the question was, can you tell me about Kamen? I said, of course, based on the provided context, here's what we can gather about Kamen. Kamen is a traveler from the teachers of the monastery of Enurek, outside of Rottenwell. That's true. His mission to find passages of the West arrives in Mungnoi. It's true. He's skilled in magic. He's able to use it to heal Jorn's injuries. That's true. He's knowledgeable about the church. It's charity work. Yeah, that's true. Is resourceful, mindful, and willingness. His way, the best route to the West, and the help of those who and help those along the way. That's true. He's also compassionate and takes time to heal Jorn's injuries before continuing his journey. So all of that is true about Kamen. Of course, there's a lot more you could do from this, but you can see that it's providing contextually aware answers from the documents that I entered, which are fantasy novels about this particular character named Kamen. So with this in mind, we can also use this same system to integrate this into an application. So I'm going to show you 2 different things here. I'm going to show you the built-in app that it provides. It's more of a reference application that you can use just to kind of play with this in a graphical user interface. And then I'm going to show you the API. I'm going to call that with Postman. And then the actual API is really simple to use, but it allows you to take the output from this particular system here and integrate it with an application that can make HTTP requests against it. So let's go look at the UI version first, and then we'll look at the API. So to run the GUI, we need to start an API, and then we also need to start the UI portion of this. So starting the API is pretty straightforward. It's just another file that we have here, and it's called run local GPT API. And so if you just run that with Python, it's going to start a Flask-based app, which is then going to start the API in the background. So the UI will use this particular API right here. And so this is going to load the same thing the other file that we just ran did, except this one is now going to have an API that we can call via HTTP instead of just entering it at the command line. So while that's loading, let's go ahead and start the UI. Now the UI is in a folder. It's called local GPT UI right here. So to get that up and running, let's just go ahead and cd into that, and then we're going to see this file right here. So we want to run this one in a different context. So I have 2 instances of WSL up and running, rather 2 sessions on WSL. And this one I'm just going to type in Python 3 and paste in that file name, and it's going to start not the local API. I want local GPT GUI.py and start that up, and that's going to provide me with something that I can run locally. But I want to start this on an IP address that I can reach externally. So to do that, I'm going to do --host. I'm going to tell it to do 0.0.0.0, and that's going to bind it to all possible IP addresses, which in this case is going to be the external IP address for my box here that's using WSL. That's the external IP for WSL, that is. And now this one is running internally. This is the API running on this endpoint right here. That's only reachable internally. So the API that this is using is exposed in a way that the application here can reach it. So let's go ahead and pull this up in a browser. And then we can pull this up and see the UI itself. So this is the UI. It's basically just a reference app. There's nothing particularly fancy about this. You can click on tutorial here and it'll give you some instructions on how to use this. But in any case, you can upload documents and do other things with this, but we're going to use the same prompt that we used a second ago. Tell me about Cammon. And we're going to use search right here, and it's going to generate a response. Now, with upload, you can actually ingest documents into this UI using the API endpoint if you want to do that. And that's basically what it's going to call. It's that ingest method that we did to ingest them whenever we copied the files from our local file system into a folder and then ran ingest. But this one is just allowing us to call that API using this reference application. So this can take a minute to generate, but once it's done, we should say something that's similar to what we saw already. Okay, so this is the output that it gave, and it says, of course, based on the particular question, it says very similar to what we saw a minute ago. It says Cammon is a scholar at the monastery of Murak. He teaches there, has commission for his work at the monastery, currently on an errand to the West Watch, and so on, depending on what novel you're reading. He has a sense of responsibility for Mon. He's got a responsibility for Rune and other characters in this. So yeah, certainly some things about this that are kind of interesting, but it didn't get some of this right. There's noting that Cammon is a complicated past of the rune. Additionally, Cammon refers to Rune as father. That could suggest a familiar or deep respect for him, which isn't true. So sometimes the responses that it gives aren't always true, but that I know is not true because Rune is not Cammon's father or doesn't have any real respect for him. They're actually kind of adversarial in their relationship at first, but eventually they do become friends. But in any case, you can see the source material that it's using to get some of these responses, and that's what this gives us. So this is the UI. Now we can get the same kind of response using the API, which is what I'm going to show you how to do now. Now the API is that first file we started, and we have to modify it just a little bit so we can expose it on an IP that's reachable outside of the localhost context inside of our WSL instance. But once we have that, we can use Postman, and I can show you exactly what this app is doing behind the scenes. So to make the API available to the outside world, we just need to edit that API file. So here's the list of files again, and this is the file that we're going to edit. So we're going to just do nano against that, or you can use VI, or if you want to edit this externally on WSL, you can certainly do that. I'm just using nano since I'm kind of right here. Now, at the very bottom of this file, there's this app run, and this is just a Flask server, which is a common HTTP server used in Python. And all you need to do is add a host parameter and make sure you put it in quotes and put 4 zeros, and that will tell it to run on all available IPs. Close it out and then start it up again, and that will then go through the process of loading the model, and then once it's ready to go, we should see it available on all available IP addresses for WSL. Okay, now we have everything up and running. You can see that I have 2 endpoints right here, this localhost endpoint and of course this one right here. So to do that, I'm going to launch Postman, and I've got an empty request here. Now, the URL for this is going to look like this. So we're going to have the IP address and that port number, and then the API you can deduce from the actual file itself. It's got basically a few endpoints that you can use to ingest things and delete documents, and then also run prompts with. So we're going to change this to a post and post against that particular prompt. Now, if you're interested in the actual parameter, we're going to use form data, and this particular one, we're going to edit the key. Now, the key that we want to use, I've already got. So now that we have Postman up, we can start with an empty request, and we're just going to use the endpoint. You can deduce these from that actual API file itself. I'm going to put in this endpoint right here, but this is the one where you can pass prompts to. So it's basically just the IP address and the port number right there, and then of course API, and then / prompt route. Now, this is going to expect a post or a get. I'm going to use post, and then it's going to use form data. So I'm going to put in a key. It's called user prompt, and then you can put your query right here. So I'm going to say, can you tell me about Akira, who is another one of the main protagonists in this particular set of novels? And so I'm going to run this and let it go ahead and run that request. And this can take a few seconds to run. Of course, it's going to query that set of documents, that database, and it's also going to apply the model to those as well to try to intelligently answer my question. Okay, now I have the prompt back right here, and you can see that it's giving some responses. And this gives you the JSON right here. It might be a little hard to read, but the idea of this right here is just JSON data that it's pulling back from the server, and that is running it in the model. So I'm going to put this into Notepad++, and so I can make it a little bit larger and easier to read on the screen. So this gives us a response. And it says, Akira is a woman who is visited by an old man named Chalk. Chalk exonerates her father. Chalk is a secondary character. Akira appears to be a skilled and determined individual, but she's able to pick locks and chains holding her captive. She seems to have some knowledge about artifacts, and she mentions Kamen stones and paladin swords. However, she admits that she's limited experience, and yeah, all this is pretty much true about her. And Chalk has a big impact on her, and so on. So this is all very accurate information about the character Akira, and it's summarizing some of this from these documents down here. So Enemy of My Enemy right there is one of them. Legacy of the Legend is another one of my novels. Shadow of the Demon is another one, and of course Legacy of the Legend of the Legacy is another one. So these all have context related to this particular character that I asked it about, and it's just summarizing some of that information up here. So again, a fairly intelligent response. And so this is what you could expect from an API call using this. So you could take this same API and embed it inside of your applications and use it to create applications using this. So this is one way to do this, though. I'm going to attempt to provide more context to this as we look at this further in a future video, where I'm going to look at the OpenAI implementation on Azure, where we're going to do basically the same thing, but this one is going to provide us with more contextual data using a very simple model relative to something like ChatGPT 4 against the same data, though. And that particular model has, like I said, trillions of parameters, and I can also ingest data into Azure and then get responses back from Azure and get similar results like we see here. So look forward to that video. But if you have questions about this, please do drop me a comment in the comment section down below. Also like and to subscribe to the channel, and look forward to more AI related content as I kind of delve into this further. And I'm going to be certainly be doing more videos around generative AI and other AI topics as well.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up, or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at TheOneMule. And as always, thanks for watching.